assume it is normally distributed according to central limit theorem, correct? So this is the middle. Yep. Then we have the confidence level. So the confidence level, it can have different percentage, up to you. If you have a greater percentage, means the confidence interval going to be wider. So that is called confidence level. Can someone briefly tell Mr. what is the meaning of confidence level? Huh? Can someone tell me? If we were to examine the possible samples of mean, each of size n, then each sample mean will create its own interval, correct? And we are 95% of this many interval will capture the true population mean. Yep. So that is the meaning of confidence interval. Okay, so now, so that means we have the lower possible and we have the higher possible, correct? This is the lowest predicted value and this is the highest highest possible value. Am I right? Okay, so now, if we turn this to a z-score, can you tell me what is the highest possible z-score and lowest possible z-score? Based on the 95% confidence? Can you tell me what is the highest possible z-score and the lowest possible z-score? What can I do to get these two values? What formula should I use? Or what program should I use? Can someone tell me, please? Hello? You go stack test? No. I'm talking about the z-score, standard score, standard score. I'm talking about the standard score. Young people? Yeah, I can use inverse norm. So inverse norm, so what do I put? 0.95, comma, 0, comma, 1, then I put center. All right? If those without that, what should you do? You should put inverse norm. What is it? Inverse norm what? 1 minus 0.95 divided by 2, 0, comma 1. Okay. So, may I know what is the answer? What your calculator give you?
I got negative 1.96 and positive 1.96.
Yeah, you got negative 1.96 and positive 1.96. Yeah, so if you do this one, you'll get negative 1.96. Am I right? So that means here is negative 1.96. Here is positive 1.96. Got it? Okay, so now, can I let the highest be H and the lowest be L? So what is the relationship between z-score and xn? Still remember this formula? Yep. Isn't it? So we assume the sample mean is the center. So the mean of this population is the sample mean. And the standard deviation of the sample distribution is the standard deviation of the population divided by, according to central limit theorem, divide by, Ashley, can I have the answer? Hello? Divide by what? Square root of n. This is sampling distribution. Is it the individual value of x? No, this sample mean distribution. So now, I told you I let h be the highest possible predicted. So my h minus the center divided by the standard deviation is equal to what? Is equal to what? Huh? Yeah? Adriana, is equal to what? Adriana, can I have the answer? I'm using this formula. Adriana, can you tell me equal to what? Adriana, can you hear me? What do you mean by hold on? What is so difficult to what are you calculating? You don't have to calculate at all. Am I right? Okay, Cindy, may I know what is equal to what?
Is it 0.96?
Why is it 0.6?
0.96 because hash is 1.96 minus
Is
0.
it is h? Why? This is the value of your x. Okay, I think this is the value of your x. And this is the corresponding z-score.
So directly 1.96.
Yes. So my highest possible predicted value minus my sample mean is equal to 1.96 times standard deviation of the population divided by square root of n. And so your highest possible value will be your sample mean plus 1.96 standard deviation. So you can predict the highest possible by using this formula. If you don't have a GC. And can this value change? Yes. So this whole thing, we call it sampling error. This whole thing, no, we call it margin of error. So it go up. So this is called the margin of error. So this go down, so you use minus. So if I want to go by the formula, it will be the lowest minus my sample mean divided by the standard deviation of the sample mean distribution will be equal to negative 1.96. So your lowest possible will be plus minus 1.96 standard deviation. So this is called margin of error. And this part, so you have to be very careful. So you plus, go up, one margin of error, go down, one margin of error. So this one, you don't have to know how to get the formula, it's okay. So, and this one, this part, oh, sorry. Okay, I'm going to circle with red. This one, the standard deviation of the sample mean distribution, correct? This one, we call it sampling error. So you have to know the difference between sampling error and margin of error. Margin of error is based on the confidence level. So from there, if you look at your textbook, we derive a formula for true predicted estimated true population mean by using the formula. So for you, you don't have to, but you have to know. Okay, so this is to get the confidence interval, the formula. Yeah. So what do we call this? So exam, they can ask. They can ask, okay, what is this? They can ask you, what is this? So you say there is a margin of error. That means the error that I allow myself to make, that's called margin of error. And what is this? Can someone tell me what is this? Point estimator or mean of a given sample. For this case, it's called mean of a given sample. So that means you base on a given sample mean, make a prediction of the population mean, yeah, with this margin of error. Got it? So that is the whole formula all about. So those without calculator, they still can count with this formula. So now the issue is this. Yeah. So we have. So first of all, whenever you want to find the confidence interval, what must you have? Okay, what must you have? What must you do? Okay, you must state your confidence level first. Okay, you can do this first. State your confidence level. So if my confidence level is 95%, so can you tell me what is my margin of error? All right. Okay, in my confidence level is 90. What is my margin of error? Okay, who can tell me? Just how you remember how you take the 1.96, now do the same. Someone have given me already. So can you get the answer? Okay, I'm going to call someone to give me the answer. Huh? If you don't know, you have a look at here. Okay. Done? Okay, Gerald, can you give me, Miss Do, the answer? What number must I put in front of the standard sampling error? Gerald? Yushan? Or Yishan?
Huh?
Okay. Okay. May I know what number must I put here if my confidence level is 90%?
1.64.
1.64. Anyone in the class don't know how to get the answer? Okay, you don't want to say? You'll be in trouble. Gerald, just how did you listen? That is how you get, Gerald. Are you looking at my screen or you looking at other screen? That is a problem with your young people. You listen to my voice, but you are now you look at my screen. Now that is the way to get the answer. Hello, Gerald, faster. Can you get the answer as 1 point? Yeah. Okay. 1.64. Okay. So you see this number can change based on the confidence level. You see, as you reduce the confidence level, this value reduce. So that means the width will be different. Okay, so how about if I say 99? I just want to make sure everyone know how to get the answer. You see, the number will change. Sampling error. A number, a z-score times by a sampling error. Okay, what is the answer? Queen, can I have the answer?
2.58.
Yeah, 2.118.
58.
Yes,
58.
58. So you see, it become wider. So that means you are giving yourself more chance to capture the true population mean. Okay, state the margin of error. So second step, you have to get what else you need to do? Okay, you know your margin of error already. So what else you need to do? Can someone tell me what else I need to do if I want to find a confidence interval for true population mean? Yes? No? Ethan?
Yeah.
Ethan? After I fix my confidence level already. Okay, fair. So after that, what else must I do? If you based on this formula, correct? What else must you have? So I will put this as K because it can change. This is what I mean by my K. So what else must I have so that I can find this confidence interval?
The standard deviation and the number.
Okay, yeah. And what number?
The number of the in the sample.
Okay, so I must have this. That is sample size, right? Then I must go and collect a sample mean. Right? Then I must go and determine the population standard deviation. Okay. You get what I mean? So, but this over here, you have to take note. Usually, can you get the standard deviation of the population? Usually we can't. Usually. So what should I do? It's unknown. That means you don't know. Then what should I do? Bear in mind, I will assume the sample standard deviation as the population standard deviation. That means you got this sample, correct? You have a sample, so you take the standard deviation as the population standard deviation. So that means in your formula, instead of this divide by square root of n, you use s divide by square root of n. Understand? S is the sample standard deviation. I shouldn't put an xn here. I should put this as s only. You take this as this. You approximate, you assume. Are you okay? So then you got all this, you just put in, then you can get the answer. So for your calculator, you just key in, then the calculator will do the thing. Then we have this confidence interval, then we can justify the claim. Okay, now, look at. I told you this is the lowest possible. This is the highest possible, correct? Yep. So now, confidence interval, when you talk about interval, we have the width. So what is the width? So we will write this as W. So you tell me what is the width? Width, we will take the highest minus the lowest, correct? So we will get this 2 times. So that means indirectly, I can say that the width is 2 times the margin of error. All right? Okay. Yeah, so remember all this. Can or not? Okay, so I'm here just to introduce to you what do you mean by margin of error, which part the formula. Do you need to use your formula to calculate the confidence interval for our test? No, you don't have to. You just use your GC. Do you get me? Okay, now, so I'm going to go through some of the questions in the book with you. Okay, can you please go to page 272, question 6, example 6. Okay, so please read example 6, a sample of 60. Okay, so the moment they say a sample of 60, so what I do is, every time when I read the question, I will jot down the information. I put down N, N equal to 60. Okay, good. So now what I'm talking about, what is the parameter that I want to talk about? The sample mean weight. Okay, I want to talk about sample mean weight. Okay, what is the population? Can someone tell me? Define the population. Sample mean weight. Yep. Can someone tell me the population that we are talking about in this question? So this is your parameter that you want to talk about. Your parameter. You want to estimate the population mean weight of Yabi. So can I know the population, Brandon?
Yabbies taken from the dam.
Yeah, all the Yabis in the dam. Yeah, from the dam, correct? Taken from the dam. So that is the population. Huh? Okay, so our parameter is the mean weight that we want to study. So we want to use this sample mean. We want to use this sample mean weight to predict or to estimate the true population mean weight. Okay, this question, they got give you standard deviation of the population. So can I just put the weight as, okay, you X. So X is population standard deviation is 16.8 gram. So do you see or not natural occurrence thing? The standard deviation is very big. Things packed by machine, the standard deviation is very small. So in the exam, I also can give you two things. So I say, which is naturally occurrence, which is packed by machine. So you can know, you can distinguish by looking at the standard deviation. Because there are many factors that affect the weight. Okay, so we have that. So do we have our confidence level? 95%. Okay, so what should we do? What should we do with that one? We are not going to use formula. I'm not going to go through that formula. Okay. Can someone give me the confidence interval straight away from the calculator? You know how to key in, everyone? Sha, do you know how to key in? Sha, Emma? Emma? You don't want to answer me, pa. Go to stack, test, Z interval. Statistic, Okay, the standard deviation is 16.8 and the mean is 84.6. Sample size is 60. Confidence level is 95. Calculate. Straight away come out. Calculator. 80.349, comma, 88.85051. Okay, so when they ask you to interpret, then we have to write in words. If you look at your book, the way your book write, they say, so we are 95% confident that the population mean weight of Yabi lie between. So you can also use the word lie between. For me, I will prefer to say that, okay, so we are 95% confidence that the population mean weight of the Yabi can go as low as 80.3 gram and as high as 88.9 gram. Yeah, okay. So we have this confidence interval. You write like that, it's not interpreting. You must put it in words. Okay. So now, where is the middle of this one? Can you tell me the middle of this value? Can you tell me the middle of this value? Can you tell me the middle of this value? Can someone tell me the middle of this range?
84.6.
Is it 84.6? You try and calculate and see. Okay. So now, why I want to ask this question is because sometime in the exam, I can give you, given the 95% confidence interval, is, okay, I just simply give you a value, confidence interval of mean is, okay, 80.5 and 89.6 gram. Okay, then I ask you this question. Find the value of the sample mean. Sample mean that is used to calculate this confidence interval. Okay, so how are you going to do? Can someone tell me how to do? Hello? You know how to do? Rachel, you know how to do? Rachel? Rachel, can you suggest how to get the sample mean that I use for finding the confidence interval? Like in this example 6, this is the sample mean that I used to find this confidence interval. So how about this confidence interval? Rachel? I'm going to make it a point like that. If I call you in class, you didn't respond to me, correct? In whatever way, listen here carefully, everyone. Okay. When come to your folio, I have the right to grade you. Okay. If I don't put an action now, I tell you, afterward, you sure will give me rubbish in your folio one. I tell you. Okay, huh? I give 100 marks for your folio. If each time I call you, you didn't respond to me at all, I will take down 1 mark. I will reduce 1 mark. Okay? Yeah. The person I call. Listen here carefully, huh? Okay. So I'm going to start it now. I'm going to record now. Okay. Xin Lee. Not Cindy, huh? Xin Lee. So how am I going to find the sample mean? Like this question, I use this sample mean to make this prediction. So now I'm going to use this one, then I'm asking for this. I'm telling you, I'm asking for this. What is the sample mean used? Cindy, answer. Cindy,
Yes.
85.05. Okay, 85.05. Okay, Cindy give the answer as 85.05. Is it correct? Yes. Okay, so I'm going to call another person and ask how to get. Yep. Okay. Uma, can you tell Ms. Do how to get the answer? How we get this answer?
Add the 50% and yeah, to get the result.
Right? Is that the way to get? So then if I ask, state the margin of error. So how are you going to get the answer? Do you need to use a formula to count? No need. Why? Okay, Adriana. Adriana, how to get the margin of error? Half of the width is the margin of error, correct? Yeah, half of the width. I told you, I want the value. You don't type in what I tell you. Just out in here. Oh, we talk about which one is the margin of error. I told you already here. You don't have to use a formula to count. If you have confidence interval, you don't have to use formula to count. How to get the width? Highest minus the lowest. So half of the highest minus the lowest. Adriana, answer. Shani, answer. Okay. 84 point, huh? 1.96? Shani? Adriana say 84 point. Well, now I know. 84.6. Adriana say 84.6. Shani say 1.96. I want to faint already. Cindy say 4.55. So who give me the right answer? It's either what I say you don't understand, or my English is so bad that I think I have to take an English class from your English teacher. I told you this is the margin of error, right? So from here to here is the margin of error. So this part is equal to this part. So you tell me, if I give you the confidence interval, how to find the margin of error? Thanks, Shani. So you see, when you talk about statistics, it's English. It's not maths at all. It's the highest predicted or estimated population mean. That means the highest value of the confidence interval. Take away the lowest value of the confidence interval, divide by 2, because this is called the width. I don't know what happened. You should know what happened. So it's 9.1 divided by 2. So it's 4.55. Are you okay? So when given you confidence interval, so you have to understand what does that mean, okay? Meaning understand. Then how do you interpret it? And how to find whatever they want you to find. Okay? So if you look at example 7 is a very good example that I give you a sample. I didn't count the question didn't count the sample mean. So you have to count the sample mean, and they didn't give you the population standard deviation, and you have to count the population sample standard deviation as population standard deviation. Then put into your calculator and count. Are you okay? Yeah. So tomorrow I will talk about the other one. Yeah. So I'm going to answer question 10 with you. We are going to do question 10, page 275. Question 10. Okay. So it should be 250 gram, milligram. So what is the parameter that we are going to talk about? Can you tell me the parameter? Okay, I keep saying it means you have to understand what is a parameter, okay? Yeah, EJ, what is a parameter that we are talking about here? Okay. Okay, EJ, give me mean preservative added to a can. Correct, thank you. That is very precise. Mean amount of cannot shortcut when you write your report that time. Preservative. This is not required by this question, okay? I'm just to make sure everyone know. Added to in a can, added to a can. To a can of what? Did they say anything? To a can of peaches, yes. So be very specific. Peaches, ES, Okay, good. So that is a parameter that we want to talk about. Okay, so now, the sample size given, okay, so the standard deviation of the population is 7.3 milligram. Okay, so sample size 60, is it large enough? Is the sample size 60 large enough for this case? Can someone explain, is the sample size of 60 large enough? Kang Jiaxin. Kang Jiaxin. I'm writing down the name. Okay. Yes. Answer my question. Don't say yes or no. If I call your name and means I want, is the sample size of 60 large enough? Is the sample size of 16 large enough to make the sample mean distribution normally distributed? You say yes. Okay. Jiaxin, tell me why yes. Explain. Because according to central limit theorem, we don't know the distribution of the population, correct? So if the sample size is larger than 30, then the sample mean distribution will be normally distributed. Okay, good. So it's large enough. So I just asked to make sure everyone know the condition. Okay, so we have all that. So can someone tell me what is one of the sample mean given by the question? What is the one sample mean given by the question? A given sample mean. Is
it 242.6?
yes, 242.6 milligram. So now, how to construct that? Okay, everyone, take out your calculator and construct. You have all the information here already. Still remember? Yeah, go to stack, test, Z interval. So key in the necessary thing. 7.3 standard deviation. Sample mean used to estimate the population mean. Sample size 60, confidence level 95. So, yeah, so you got this. So we have 240.75 and here is 244.45. Okay, now, So we are supposed to write in word. We are 95% confident that the true population mean amount of preservative added to a can of peaches, okay, can go as low as 240.7 0.6. This one you have to round up, 0.6 gram. And this one you have to round down. Okay, I just want to let you know, if you want to round, this is your confidence interval. All right. So this one you have to round up. This one you have to round down. Okay, so that is within. So if you want to round, this will be 240.8. And this one is 244.4. If you want to round. Okay, but your book, they use round accordingly. So what I will do is usually I will write down, then I round, top, I round up, bottom, I round up, the top one I round down. So that is within the confidence level. Okay, so it's not out. Okay, find, done, find the width of the confidence interval. So I just take this. I just take this minus this. Yeah. Okay, explain how the quality controller could obtain a 95% confidence interval with a smaller width. Okay, can you tell me? Confidence level, I'm not going to change. This is confidence level is fixed. So how am I going to get a smaller width? Can someone give me the answer? Okay. You all keep quiet, so I call Cairo. Cairo. Okay, someone have responded in the chat. That is a correct answer. Cairo. You see? Cairo. How can I? Okay, Cairo will be the first one. Your good friend better text him, 100 mark now, he got only 99 mark for the 20%. I will jot down the number of times I call you if you didn't respond to me. Yeah. Okay. Amali, can you just tell me the answer? Some of you have given me the correct answer already.
Yes.
Yeah. How can I make the width smaller? Like the width for this one, correct? The width for the width. B, my n is 60, correct? The width is 240.75. Okay,
I take a larger sample.
Yeah, take another sample, I know.
A larger sample.
A larger sample, yes. Okay, correct. Increase the sample size. Understand or not? Okay. So the whole chapter is not difficult. It's very easy in the sense that, first of all, So now you know why we need to do sampling. Okay, can anyone tell us why sampling is important? After I gone through this confidence interval. You know what is the meaning of sampling already, correct? Now, I ask you, why sampling is important? Anyone want to try to answer? Why is sampling important? Why is sampling important? Ime, want to try to answer?
Is it to like gather data from a large like population?
Some more? Correct? That is sampling. Why? Now, when you say collect data, sample of data from the large population, correct? Okay, that is called sampling. Now I say, why is sampling important?
Is it to save time?
Okay, to save time, yes. To save time in what? Right, to save time. What can sampling, what can we make use of the sampling? Okay, maybe I put the question in such a way. What can we do with the sampling that makes sampling so important? Because you must know this so that when you write, you know what to write. EJ, want to try? Don't type, EJ, please talk. EJ? Hey, faster, 5 o'clock already, never mind. Time over, never mind. You all don't have class, right? I also don't have class, right? Okay, so never mind. We can stay on.
Is it because there's sampling variation?
Okay, so I know there is a sampling variation. So what are we going to do with the sampling? What can we do with the sampling? That is the important thing. What can we do with the sampling?
Find confidence interval.
Yes, finding confidence interval. So finding confidence interval for what? What is confidence interval? So instead of telling me finding confidence interval, okay, if we know sampling distribution, okay, how is a sampling distribution for mean look like? Then we can use one sample mean to help us to predict the true population mean that we are not able to obtain in real life. Like for example, can I know? Okay. Can I know what is the mean weight for 17 years old young people in Malaysia? Is it possible? No. So I use the sample mean, okay, and know how is the sample mean distribution of the height look like. Then based on that, I predict the true possible mean. Are you clear? So in all the questions that you have in the textbook about the population mean, correct, all are not the true situation in real life. True situation in real life is you definitely cannot know. We are not able to, the population is too huge. So that's why sampling is the most important part of statistics. We can't explain this kind of things when you study statistics at the beginning. But now, slowly you know. That's why I told you, statistics is a very large part of maths. This topic, statistics, is a lot. I only know one dot. If it is 1 meter long, I only know one dot. So you want to be actuarial science, you must be very good in statistics. So you have to understand every single thing. So why we study sampling is we can know the nature of sampling distribution, and from there help us, based on the sample, help us to predict the population parameter. Okay, whatever we learned today is the population parameter that we want to discuss about will be the population mean. The next part will be population proportion. So that is called the parameter. Clear? Hello, young people? Okay, so you please try to do all the questions in 90.1. Yep, tomorrow I will talk about 90.2, 90.3. Yep. Okay. Thank you, class.
Thank you, Miss.
Thank you, Mr.
Thank you, Miss.
Thank you, Miss.